Hi everyone, welcome back to another video. This one is primarily for students currently in my Math 265 class, that's Calculus for Engineers. Um, I had a request to go over some problems from section 1.6 of our textbook. As a reminder, our textbook is Stewart's Essential Calculus, second edition. And section 1.6 is about limits involving infinity. So I have a sample problem written here, and you'll see, okay, well, infinity doesn't appear anywhere in this yet. But the first concept I want to go over is if I divide a number by a really small number, so let's say something close to zero, less than one, um, then it's going to make it larger. What do I mean by that? Well, let's say I take one, and well, I know if I divide it by something like two, I get 0.5, right? And that's smaller than one. But if I take 1 and I divide it by something like 0.1, well, 0.1 is 1 over 10, right? And 1 over 10 is 10 to the negative 1. So this is 1 over 10 to the negative 1, but that's 10 to the 1, and that's 10. So notice I'm now something larger than 1. If I took 1 and I divided it by 0.01, similar concept here, right? So it's like 1 over 10 to the negative 2. Well, that's 10 squared, and that's 100. And just as one more example, so 1 over 0.001, this is 1 over 10 to the negative 3. We get 10 cubed, and we get 1,000. So you can imagine if I did 1 divided by 0.000001, I'm going to get a pretty big number, right? So the idea is if I take a number, oh, that's my cat, divide it by something small, then I'm going to get a large number. So that's kind of how we get infinity here, right? So think of 1 over x, that graph. So just kind of like a sketch here looks something like this, right? So as I divide 1 by something that gets closer to 0. Well, over here, we're going to positive infinity. Here we go negative infinity because I do something like 1 divided by negative 0.0001 or 0.0009, right? It doesn't have to be 0.001. The point is it's small. So let's start with this problem here. We're saying, okay, let's do the limit as x goes to negative 7 from the left. So numbers left of negative 7. Let me first, let's see, let's kind of silo this off. And okay, so here we're going to negative 7 from the left. So I can imagine, whoa, let's see, here's negative 7. Let's see, here's negative 8. And, here we have like negative 7.5, let's say. All right, so looking at this, we have 1 divided by, okay, so something squared. If I have like negative 7.5 squared, well, this is going to be a positive number. Positive number. But then here we have something like, let's say negative 7.5 plus 7. For example, this is going to be negative 0.5, right? And as I get closer and closer to negative 7, so I could have like negative 7 point, let's say like 0.1 plus 7. This is still going to be negative 0.1, right? Or 0.01. So the point is, all right, we have a positive number times, this is going to be negative since we're approaching negative 7 from the left. And this is going to 0, right? So if I have negative 7.00001, I'm taking 1, dividing it by, well, this number, something positive squared, but then I'm still multiplying it by something that's going to 0. And okay, so we have positive. We saw the x plus 7 is going to be a negative number. Positive times a negative is a negative. So this limit's going to be what? Negative infinity. And oops, I wanted that to be a box. One thing I forgot to say at the start of the video is, you can do these problems with a calculator, right? Like you can open Desmos, you can plot this and you can say, oh, okay, if I look at the graph, as I approach -7 from the left, we'll see that this is going to shoot down to -infinity. But I also wanted to show you how to do these kinds of problems just, by inspection using algebraic methods. So, here's how we can do these kinds of problems without a calculator. All right, let's do a couple more practice. This next one here, all right, we're saying limit as x goes to 5. So, okay, they're not giving us a left or a right limit here, so let's think about that. And we're doing 2 divided by x minus 5 power of 6. Well, I'm raising something to the power of the 6, so the denominator is always going to be positive. So this is always going to be a positive number divided by a positive number. So we know all together, all right, we're going to get something positive. Well, okay, if x goes to 5 from the right, maybe I'll draw our number line for us. So let's say here's 5. And let's say here we have, 5.1. And let's say here we have 4.9. So, okay, if we did 4.9 minus 5, well, that's negative, but to the power of 6 is positive. 5.1 minus 5, well, that's positive, and I raise it to the power of 6, still positive. X minus 5, well, that's going to go to 0 as x approaches 5 from either side. So this is going to be 2 divided by a small positive number. This small positive number is approaching 0. So what should the limit be here? Well, it's going to be positive infinity. All right, 2 more problems I want us to do. So now let's take a look at problem 3. So we're taking 2 divided by x minus 3, and we're taking the limit as x goes to -3 from the left. So let's say here's -3, here's -4. And okay, so we're getting close to -3 from the left. So these are things like -3.5, -3.4, -3.001, for instance. So, okay, we're taking 2 and let's say -3.1 minus 3. This is going to be negative, right? So 2 divided by negative number, denominator is going to 0. So this is going to be negative infinity. Again, positive 2 divided by negative number, this is going to be negative. One more example. So we're taking the limit as x goes to 5 from the left. So these are numbers smaller than 5, and we're raising it to the power of 3. So something smaller than 5, we could think 4 minus 5, 4.5 minus 5, 4.99 minus 5. So this is going to a difference of 0 in the denominator, but because we're doing something smaller than 5 minus 5, that's going to go, it's going to be negative. Negative cubed is negative. So we have 2 divided by a small negative number. This limit's going to be negative infinity. All right. So again, quick video. I just wanted to go over how to do this using our regular algebraic methods. One thing I'd recommend you all do is try plugging these functions, so not the limits, just the function part, into Desmos. Take a look at what happens as, so for instance, for this one, look at things to the left of 5. As I approach 5 from the left, you'll see the function's going to shoot down to negative infinity. So let me know if you have any questions. Thanks for watching, and I'll see you all in the next video.